Hey everyone, and welcome. You ever listen to top engineers talk about building software? It's like they have this secret language, right? This alphabet soup of acronyms that really represent these core design philosophies. Well, today we're going to decode that language. CAP, ACID, BASE, SOLID, and KISS, and turn them into really powerful tools for your own thinking.
Okay, so what are all these acronyms, and why on earth should you even care? Because honestly, understanding them is the key to understanding the trade-offs behind pretty much every single piece of software you use, from your banking app to your social media feed. These aren't just buzzwords, they're literally the blueprints of our digital world. All right, here's our game plan. We're going to start with the big principles for managing data, then we'll zoom in on the rules for writing really clean code, and finally, we'll see how it all clicks together. So think of these acronyms less as, textbook jargon you have to memorize, and more like years of hard-won lessons, all boiled down into these foundational philosophies. They help architects decide exactly how a system should behave, especially when things start to go wrong. Okay, first up, let's dive into the world of data. And this is where we find these two heavyweight champions, two powerful and competing ideas that are constantly in a tug of war, forcing engineers to make a really critical choice. And right here, you can see that core conflict laid out. On one side, you've got ACID. This is your traditional relational database. Think MySQL or Postgres. They prioritize strict, unshakable consistency above absolutely everything else. On the other side, you've got BASE. That's the philosophy behind a lot of modern NoSQL systems, and they choose to prioritize constant availability, even if it means things are a little inconsistent for a moment. First up is ACID. It stands for atomicity, consistency, isolation, and durability. But honestly, the easiest way to get it is to think about a bank transfer. That transfer has to be atomic, meaning it either fully completes or it fails and absolutely nothing changes. It's all or nothing. It also has to be consistent, isolated from other transfers, and durable, so once it's done, it stays done. Perfect reliability. Now on the flip side, you have BASE, which stands for basically available, soft state, and eventually consistent. And the perfect example here, your social media feed. When someone posts something, it might not show up for every single one of their followers across the globe at the exact same millisecond. The system is always available to take new posts and show you something, and it just guarantees that eventually everyone's feed will catch up and be consistent. It's a much more relaxed model, really built for massive scale. So that begs the question, right? Why do we even need this whole ACID versus BASE to beat? Why can't we just have it all? Perfect consistency and perfect availability. Well, there's a reason, and it's called the CAP theorem. Think of it like a law of physics for distributed systems. It's just inescapable. Okay, so let's break down the C in CAP. Consistency. This is the one source of truth guarantee. It means no matter who you ask, what server you hit, you always get the absolute latest, most up-to-date data. No exceptions, no maybe this is the latest, just the facts. Then we have the A, availability. This one's super simple. The system always answers the call. Every single request gets a response. Now, it might not be the very latest bleeding-edge information, but you will never, ever get a server is down error. The lights are always on. And last, but definitely not least, the P, partition tolerance. This is all about the system's ability to keep on chugging even when the network between servers gets flaky or just breaks down. And let's be real, in any big distributed system, network failures aren't an if, they're a when. So this one, it's totally non-negotiable. And here's the punchline. The whole point of the CAP theorem is, you can only pick two. You can't have all three. And since we just said partition tolerance is non-negotiable, that means you're forced to make a really tough choice. A banking system? It's going to choose consistency and partition tolerance. It would much rather be unavailable for a moment than show you the wrong balance. But a video streaming service? It'll pick availability and partition tolerance every time. It'd rather show you a slightly older recommendation list than an error screen. That's the fundamental trade-off. Okay, so we've been talking about these huge macro-level laws that govern entire systems. But what about the rules that govern the actual code inside those systems? Well, that's where we zoom in from the big picture to the nitty-gritty with the 5 solid principles for writing clean, maintainable code. Now, solid isn't some single magic bullet. It's more like a toolkit. 5 solid guidelines to stop your code from turning into what developers call spaghetti code over time. The goal is just to create software that's easy to change and easy to understand, so you don't accidentally break one thing while you're trying to fix another. Now, we're not going to do a deep dive and master all 5 of these today. That's a whole other topic, but let's just grab the first one because it's probably the most important, the single responsibility principle. It's a simple idea. Every piece of your code, every class, every module should be responsible for just one thing. For instance, a part of your code that handles user login shouldn't also be in charge of sending marketing emails. By keeping those jobs separate, your code just becomes way easier to fix, test, and upgrade. The other 4 principles all follow that same spirit. All right, after all that, distributed systems, object-oriented design patterns, it gets pretty complex, right? Well, now we come to what might be the most powerful, most universal, and honestly, the most elegant principle of them all. Keep it simple, stupid. That's it. That's the KISS principle. And it is such a powerful gut check, a reminder that complexity, that's your real enemy. Whether you're designing a global system or just writing a single line of code, the simplest solution is almost always the best one. It's easier to build, easier to debug, and so much easier to maintain. And this is not just some catchy phrase that developers throw around. It's actually a formal design principle that came from the US Navy way back in 1960. They wanted to design jets that could be repaired out in the field with just basic tools under combat conditions. For them, simplicity was literally a matter of survival. And that philosophy is just as critical for building software today. So let's pull it all together now. We've gone on quite a journey decoding this alphabet soup, right? We've seen the huge trade-offs you have to make with data, and we've drilled all the way down to the principles for writing just a single piece of code. You can really see the pattern here. The CAP theorem forces you to make that choice between the philosophies of ACID and BASE at the huge system level. Then SOLID gives you the rulebook for actually building the pieces of that system. And watching over all of it like a guiding star, you've got KISS, that universal reminder that no matter what path you choose, simplicity should always be the ultimate goal. And that really brings us to the final question I want to leave you with. As the systems we build get crazier and more complex every single day and the demands just keep growing, which one of these timeless ideas do you think is the most critical for the future? Is it that rock-solid reliability of ACID, the incredible scale you get with BASE, the clean craftsmanship of SOLID, or is it just that simple, elegant wisdom of KISS? It's definitely something to think about. Thanks so much for tuning in.